Calculus! All right, today, AP Calculus, lesson 6-1, slope fields. We are here on this December 7th, 12/7. All right, so slope at a point. Everything today is just how to find slopes at multiple points, and when I have a differential equation, that slope will be interesting. So on the left-hand side, we have a dy dx where we have an x and a y. On the right-hand side, we just have an x, and we'll see how that compares when we make our slope field. So when I have this guy, dy dx, again, another name for dy dx is what?
Derivative?
Yeah, derivative of, with respect to?
Oh, with respect to y.
With respect to x in this case, because it's still with respect to x. What's another name for dy dx? Whatever, we have like 7 synonyms for dy dx. What are they? Or some other ones? We have f prime, I guess. Yeah, that would be one way. What's another one?
Y prime?
Y prime, yeah. That's actually a short one. I can write it right there. Yeah. What other things do we have? Starts with a T. Yeah, tangent. All the synonyms that we have, perfect. So it can be y prime, it can be the rate, it can be f prime, whatever you're talking about, but you have some function where you took the derivative. This is the derivative, and I just want to make the note that this includes x and y, and this one does not. This one only includes, so this one is only in terms of x, and that does happen. Maybe it's only x, maybe it's only y, maybe it's both x and y, and we'll see what happens. So evaluation bar, I'm plugging in 1, 1, so I don't know if we've seen this before, but just generally, whenever you have an evaluation bar, it says plug in these numbers. And if I have multiple things to plug in, usually you just go alphabetical order, x and y, because x, y, z. If I had a third number, then it would match to a third number, hopefully. But generally speaking, if I have a y and an x, I'm going to have 2 numbers that I always plug in. One is x, one is y. So when I plug in x comma y, what do I get? What number pops out here? It is 0, yeah, because you get 1 is x, and 1 is going to be multiplied by 1 minus 1. I plugged in 1 for the y. 1 minus 1 is 0. 0 times 1 is 0. So that is equal to 0, which means the slope there is 0. Or so let's say slope here is equal to 0, or the rate is 0. So there's no change happening at this point 1 comma 1. What happens if I plug in 2 comma 3? What do I get? It would be 4, yeah, exactly, because you have 2 times the quantity of 3 minus 1. I forgot my parentheses when I substituted in. 3 minus 1 is 2. 2 times 2 is 4. So at that point, it is a slope of 4. All right, let's try this one. Again, I'm still plugging in x comma y. It just happens to be there's no y. And if you prefer, you can write it like this. You can say 2x plus 0y if you want a y in there, but you don't have a y. So if you don't see a y, don't plug in anything. So I'm plugging in 1 for x, 1 for y. What do I get out? Just 2, yeah, because 2 times 1, that's 2. That means we have a slope of 2. And when I plug in negative 1, I get, yeah, just negative, wait, say it again? Yeah, negative 2. Yeah, because negative 1 times 2 is negative 2. Okay, and then what does that mean in terms of our definition of f increasing, f decreasing? On this problem right here, is that f increasing, f decreasing, what's going on?
Y is greater than 0.
F, so yeah, f increasing is where what happens? What's the definition?
When f prime is greater than 0.
F prime is greater than 0. And since this is f prime, another name for this is f prime, that means what's happening here at 0? It's not f increasing, right? Because it's not greater than 0. Is it f decreasing? F prime would have to be less than, exactly. So it's neither increasing nor decreasing.
Is it FCV?
It is a CV, yeah. So this is just a CV. All right. What about this one? What definition do I have? Is it a CV, F increasing, F decreasing?
Increasing.
Yep, F increasing. What about this one over here that is evaluated to 2? That's F increasing. And what about negative 2? F decreasing. Perfect. Perfect. So differential equations. What do they look like? If you ever see any of these things, that means it's a differential equation. Here they are. If you see dw dt, that's a differential equation. If you see technically dy dx is a differential equation. We just saw that right above. What else do we have? Just anything d something d anything. So I don't know, dy dt with respect to time. It doesn't have to be with dt, but usually it's dt or dx. So I don't know, let's choose another random letter, d capital B of dt. Usually it's with respect to dt or dx, but it can be dw dz. It usually is in the bottom because it's usually a rate, so how fast you're going per time. So usually that, but it's not always the case. I would say on AP tests, it's gonna like always be dt or dx on the bottom. I don't think on the AP test, at least, I've ever seen that change. All right, so types of slopes. This is a review of Algebra 1. If I have a slope of 0, what type of line do I have? What is the slope of that line, rather? Go with your arms. Slope of, yeah, it looks like that. Go ahead and draw it. It has a slope of 0. And I can make all my lines slightly larger here. I'm going to go to, sure, 2.4 font. What about slope of 1? What does that look like? Make it with your arm. Yeah, so you need to be able to draw a slope of 1 without any handicap graph. So this is a slope of 1. It goes right 1, up 1, right 1, up 1, right 1, up 1, etc. Slope of -1, make it with your hand, your arm. Slope, yeah, it goes the other way. Yeah, exactly. So it goes like that. It goes down. All right, what about a slope of 2? Make it, yeah, so it's steeper. And make sure it goes right 1, up 2, right 1, up 2. So it looks like this. And slope of -2, make with your arm. Yeah, it goes the opposite way and still steep. Perfect. So you need to be able to draw those on your own. So just be wary of that. Anything else I want to say here? Obviously, dy dx of 2 has a steeper slope. So I just want to make this note. I know it's obvious to us right now, but I just want to make sure that we, oh, that's not the right tool. I just want to make sure that we know what's going on. So this line is steeper than that line. 2 is steeper than 1. Okay, now we're going to actually do our first real AP calculus question that you might see. By the way, I haven't made this note yet, but all of Unit 6 right here, everything is free response for the test. There's no more multiple choice. We're done with multiple choice until we get to the final. Actually, I think there's 5 multiple choice questions each time just to make sure I get review in there, but all of our new material is always going to be free response. So just a heads up. I'll talk about how to,
for the rest of the year.
For the rest of the year. Yeah, and I'll include a few multiple choice in there just to get our review from Unit 1 through 5.
But we've learned everything that's going to be multiple choice on the actual AP exam?
Not everything, but most things. Yeah, the way that I'm designing these units, or that John designed these units, are that each unit is for one specific AP question that gets asked every year. So slope fields, or antiderivative applications, slope fields get asked every single year. So we're learning how to do that free response question. All right, so on the AP test, they say dy dx is equal to 2x, and they give you this graph right here with a bunch of dots, or they might not have dots. Usually they give you dots, and they say, okay, what is the slope at each one of these 25 dots? So you're doing the same thing that you did up here. You're evaluating, you're plugging in the x coordinate, the y coordinate to the derivative to find the slope, and then you graph that slope. Let's do it. So when I'm graphing the slope at, I'm going to start it doesn't matter where you start, you can start anywhere. I'm just going to randomly choose the top left. So that has a x coordinate of -1 and a y coordinate of 1. So when I plug in -1, 1 into my derivative, what is my slope? It would be -2. So I need to graph -2. Do that. Has a slope of -2. Okay, when I graph -1, 0.5, what is the slope? What, -1.5, this point right here. It's the same. In fact, you guys have already seen that it's going to be the same because it doesn't matter what our y coordinate is because there's no y in here. And that's kind of the huge thing. So if there's no y, then when you move up and down, you're going to have the same slope. Or if there's no x, when I move left and right, I'm going to have the same slope. So draw this, the slope of -2 over and over for all of these points that go straight up and down. So
Is that what all you have to do on the exam?
yeah. Well, I mean, this would be one of 3 parts on the exam. They would, like, question 1 would have part A, B, and C. This is all part A right now that we're doing. All right, so now when I go over to -0.5, what is my new slope for this entire x-axis, or this entire line of y equals -0.5? Or it's not y equals -0.5, it's x equals -0.5. What is the slope? So for example, what is the slope here at -0.5, comma 1?
-1.
-1. And when I move down to -0.5, comma 0.5 to this point right here, what is that slope going to be? Just shout it out. Same. Yeah, they're the same for this whole line of x equals -0.5. So let me drag these down here. Drag these down. Oop. Drag them down here. Drag this right there. All right. What about x equals 0? This entire x-axis here. When x equals 0, the slope is 0. Go ahead and graph it. Go ahead and just graph the rest of them, and you can check up on the board to see if you're doing it the same as I am. And then I guess my other color is black. All right, everyone has the following graph, more or less? Okay, I want to ask you a question. If I actually were to graph the graph of y, not dy dx, but the graph of y, what would that look like? So what is the antiderivative of 2x?
X squared plus c.
X squared plus c, exactly.
That's why it could be, like, that's why the y value could be anything, because we don't know what the y-intercept is yet.
Yeah, do you guys see it? So what Ben is seeing in his head, and you might be seeing it too, is I could have this graph right here. It could look like this. 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 I don't know where the y-intercept is because I'll have, when I take the antiderivative, I'll get y, and I can maybe write this over here because it'll make more sense. Y is equal to x squared plus c. That c is going to be this vertical translation up and down. That's why this graph makes sense. And you don't always have to make sense of it. In a lot of cases, you can't make sense of it. But it does match in this case, so you can clearly see what's going on. I can find the slope at that point. It will be as if I had a c at a certain point. Questions thus far? All right, that is it. I don't think there's any backside. Yeah, so that's it for the notes. Go ahead and write your summaries now.